In today's video, we're going to be covering drilling and tapping of these holes here. I might have forgotten to mention that it's always important again to be labeling your tool paths here. So right here I've got rest machining of the main pocket here. So that's under again in tool. You're going to enter your text right there. Just make sure you do that for all your tool paths. It's good to get into the habit of doing it as you select your tool. So drilling and tapping is a quite simple machining operation. There's a couple of things that you'll need to keep in mind, however. And you'll also need to note that there are no hole callouts for the size of these holes on this solid model. So usually when you have a part, especially if you've designed it, you'll have the drawing already or it will be provided for you. In this case, I have the drawing here accessible through the Titans of CNC website, where they also have a programming tutorial here as well. So right here I've got my drawing, and second page I have my hole callouts. So I can see here that they're a 1032 UNF 2B tolerance. So I don't know off the top of my head what the drill size for a 1032 tap is though. So I have a drill chart here pulled up that shows my drill sizes. So for a 10-32 right here at the bottom, I'm going to be using a number 21 drill. Okay, so I need to use a number 21 drill. And if you've done any manual machining yet, you'll know that when you're drilling a hole in metal, you want to do what's called center drilling, or alternatively known as spot drilling, where you basically put a little tiny indent at where you're going to be drilling your hole, and that allows the drill to drill perpendicular to the face, prevent it from walking around the surface here as it enters the material. So a very important step, especially in harder materials. So let's get started. We'll create a drill toolpath. Alright. So in this instance, you can see they actually modeled the threads into the part, which I usually don't like. It's better for, as a CNC programmer if those are just holes with the appropriate callouts on the drawing. Alright. So as you can see, it's just a helix, so really can't select the center of a helix. But you look down in this, you can see right there, there's a center that you can easily choose there. So to easily select these, what I'm going to do is position this sort of like so, and I'm going to turn off my shading so I can do Control T, and that's going to turn off my shading. And with any other chaining mechanism, I'm going to start selecting my holes, and I want to make sure that I choose the center of those holes and not the apex of the radius like this. So I'll go ahead and I'll choose the center of that hole, and I'll shift pan with the center click wheel and progress around my part, selecting all of my holes. Here we go. Again, keeping in mind not to accidentally select the edge of that hole. Perfect. So I've got all 7 of my holes selected there. It's going to bring me right back into my parameter screen. So in this case, I can use either a spot drill or I can use a center drill. I prefer the spot drill on a CNC, but it's really up to the user. Filter, I can choose my spot drill right there or my center drill right there. In this instance, let's use the spot drill. Oops. Double click. We'll use the 1/2" spot drill. I've already selected one already before, so I'll actually just not add another, but you won't have that issue. Select my spot drill here, and I'm going to put in a random depth, or sorry, not there yet. Put in a comment spot the tapped holes. Alright. In my cut parameters here, I want to make sure that this is set to just a standard drill or counterbore cycle. And then the final thing is to set a depth in absolute. I'll choose start with -0.07 and we'll see how that looks when we backplot it. And I'll click OK. So let's go ahead and take a look here. As I can see, I've already got a problem. None of my toolpaths are above the part, so I can see my linking parameters are a little messed up. I'll turn off that shading and we'll find something that works. So going back into parameters, I can see my retract is incremental. So from the bottom of that hole where we selected geometry is actually where it's getting that incremental retract from. So let's turn that to absolute. Okay. Now if I wanted a quick view without going out of the toolpath manager here after I've made some changes, I can actually click this button, preview toolpath, and that's going to display the changes made. Alright, so I like to use that in this type of instance. It's very convenient. Now I don't like how high this thing is starting its feed motion. That's just kind of cutting air and it's a bit of a waste of time. So I could change this to say 0.1 and we'll take a look at what that looks like. Okay, so that would be fine. One thing I would be a little worried about here is if I had a feature in the middle that was, a boss or a feature that stuck out, I might actually run into that when it's doing a move, a rapid move. So I can also add clearance, and we'll do absolute, and we'll do 1 inch of clearance. And you'll see now it's got a rapid feed. Starts here, comes rapid, and then starts feeding, and then retracts all the way up to this safety zone, essentially. We can leave that in there. Better safe than sorry. Yes, I'll save. Okay, so we've got our spot drill. Let's take a look, and I'm going to use the S key, and I'm going to step through here. See how deep that guy goes. Okay, so that looks like a good depth. It's not going too deep. It's giving a nice entry point for our drill. If you go a little bit deeper to leave an automatic chamfer on there, so let's take it up to 90 thousandths. Oops, 90 thousandths. We'll regenerate and check again here and see. Okay, so it's giving just a tiny little chamfer. We'll leave that as is. It should be perfect. All right. So, in the sake of saving time, what I like to do is simply copy these just like we've done before. So I'll right-click, hold that right-click down, and I'll drag down here and copy after. Make sure to move my insert arrow again. Okay, that way I don't have to reselect any geometry, and I've got everything I need. So we'll go into the new toolpath, and we'll immediately change our comment here to drill the tap holes. Okay, so we'll go into and select our library, and we're looking for number 21 drill. We've got letters, we've got fractional numbers, and we've got number drill. So you can see the fractionals up here. As we go smaller, we've got numbers are the smallest, and then letters are in there as well, letter H, letter I, etc. So we want number 21. Sorry about that. There we are, number 21, and we'll choose that. Okay. And in my cut parameters, what I want to do in this case, this is a relatively deep hole compared to the diameter of the drill. If this was plastic, I could probably just drill straight through without doing a retract in between a pecking cycle, and that's just because the material is so soft. In this instance, however, we want to actually do a pecking cycle. So that's going to go in, come out, go down deeper, come out, etc. until it reaches the final depth. That's to clear chips and to prevent drill breakage and clogging of the flutes. So in this case, I can probably do a 0.25 safely. And final thing, linking parameters. Now this is where we want to choose our drill depth again. So in this case, we use the depth button. And I'll turn off the full shading there so I can see where I'm going. Now you can see in the model that it's got the drill point feature cut out there because they were probably using something like Hole Wizard. So I can select this, and with that much clearance between the thread and where the drill goes to, that should be fine. But if I wanted to get this perfect all the way down to there, I really can't select that imaginary tip. So we'll choose this, and then let's subtract minus 0.025 to that. So 0.605. We'll click OK, and we'll regenerate that toolpath. And we can see from there, we didn't quite get to the tip of that, but that's okay. We could modify that if it was really essential. In this instance, we don't have to really worry about it. Okay, so let's back out of here and take a look at our back plot. Especially with drill cycles, I prefer to use the S and B functions on my keypad so I can really see what's going on. Okay, so where am I at here? So S, so you can see it goes in, comes back out, goes in, comes back out, and goes down. And that's just, again, allowing for the chips to be cleared out. If this was a stainless steel, I would run a much shallower peck level. The harder the material, the more you have to worry about drill breakage. So that looks good. We're going to go ahead and simply copy and paste that toolpath right there. Copy after. As you can see, drilling is pretty straightforward overall. Go right back into our parameters and immediately change our comment here to tap the tap holes. And we'll choose our 1032 right-handed tap. Filter that out. Got the right hand and left hand. I've never actually used a left-handed tap on this, but you can. Right hand tap. And we simply choose, oops, I always forget to double click. Simply want to choose our 1032 number 1032 there. Okay. Cut parameters, very important here. We want to make certain, absolutely certain, that we choose rigid tapping cycle. What rigid tapping cycle does is it perfectly synchronizes the spindle speed with the feed rate. If you think about that picture, this graph or this graphic right here, you can see that it's a helical shape, right? So you need your spindle speed and your feed to synchronize. Otherwise, you're going to compress fracture your tap, or you're going to pull it apart when you come out. So you need to make sure that your tap is synchronized. That's what the rigid tapping cycle does. Now, in the machine that I actually use in the shop, it allows for a pecking cycle. But for this demonstration, we won't worry about it. In linking parameters, I want to change my depth. Choose that, and we'll go and find the bottom of that helix here. So right about there. Now, taps are generally tapered at the end, right? So if I go to that depth, the tip of the tap is going to go to that depth. But you won't get a full thread. You might get a full thread to this point right here. So we want to actually extend that a bit, and because there's so much clearance down here, we can actually extend it a pretty good bit. So let's go to minus 0.5. Sorry. Take a look at that regenerate here. Whoops. So you can see our tap is going pretty deep, a little deeper than necessary, but again, we've got all that clearance, so it's not too much of an issue. So let's go ahead and backplot, or sorry, simulate all of that using the verify function. And we'll see what our part looks like. Okay, so we've got all of our holes drilled and tapped here. You can see the little step right there. That yellow is our tap and the blue is our drill. Okay, so this part is practically done. Now, I could leave this as is, as a complete part. You know, we're pretty much there. All the features have been completed. However, I like to finish up my parts and make them nice and handleable so that we're not gonna, have any issues when handling this part, sharp edges, etc. So in the next video, I'll show you how to do a chamfer mill, and that'll break all of those edges and make them nice and clean. Okay, see you in the next video.